As you turn to page 5 of your notes, we're going to review the real number system and a special type of number within it called an integer. An integer is a whole number and the opposite of each whole number, including 0. So for instance, two numbers are opposites if they are the same distance from 0 on a number line. If 3 is an integer, then its opposite, -3, should be as well. If I have a number 4, which is an integer, it happens to be a whole number, then -4 would also be considered an integer. Now, as you add this to your notes, please make sure you include whole numbers or their opposites and 0, and then please add in a few other examples to your notes. As we turn to page 4, or look at page 4, which is on the left-hand side of your notes, we need to talk a little bit about what is absolute value. So this might have popped up last year in 6th grade. How do we know what absolute value is? Well, it works with integers. You're going to notice that I have the integers on a number line below from -4 to 4. So an absolute value of a number tells us how far away that number is from 0. So for instance, if I put a dot on the number line at -1, I want to know how far away is -1 from 0. So if I go from -1 to 0, how far away is -1 from 0? Well, it's 1 unit away. So the symbol for absolute value looks like this. Kind of looks like two vertical lines with a space in the middle. If I want to know what the absolute value of -1 is, I would put it inside that symbol, and it would tell me how far that number is away from 0. Okay, let's try another one. Let's look at 4. If I wanted to find the absolute value of 4, meaning how far away 4 is from 0, what I'm going to do is count back to 0. I'm going to count back 1, 2, 3, 4, and sure enough, 4 is 4 units away from 0. Absolute value is going to help us solve problems later on in this unit, so write down any important information that you have about absolute value on page 4. All right. Now we're going to turn to page 7, and we're going to start to now add integers. We just learned that integers were all the whole numbers in our number system and their opposites. We also know that 0 can be included. So today we're going to add integers using number lines, which you can see on page 7. You're going to notice that we're going to use some numerical chips or chips that represent numbers, and then we're going to talk a little bit about how we can make the rules. So let's go ahead and start with our number line. So instead of saying 4 plus 2, this says 4 plus a -2. How do we work that on a number line? So what I'm going to do is start off with a black dot to represent our 4. I'm going to go ahead and put 4 just above the number line. You can put it on your number line as well. So there I am. That's where I'm starting at 4. And then if I add -2, what I'm going to do is I'm going to move that dot 2 to the left, because anytime I subtract on a number line, I'm going to move to the left. If I add on a number line, I'm going to move to the right. So I'm going to move 2 places to the left. Oops, I don't want to do that. Sorry. I'm going to move 1, 2. Now, if I start off at 4, that means that I would be going from 0 to 4. And then I'm going to go from 4 to 2. And my final answer here is 2. So let's review that number line one more time. I'm going to start off, if I even want to start up at 0, I know I'm going to go to 4 and put my dot here. And then if I subtract 2, or if I add a -2, I'm going to move 2 to the left, and sure enough, 2, where I end up, is my answer. Now I'm going to show you with integer chips. So just so you know, with integer chips, a black chip represents a positive 1, and a red chip represents a -1. So I'm going to draw this out. I'm going to put 4 black chips, 1, 2, 3, 4, and I'm going to put 2 negative chips, 1, 2. Now, what I'm going to be looking for is ways to make 0, because I want to know what's left over. So anytime that I have a positive 1 and a -1 come together, it's going to make 0. So if I have a positive 1 and a -1, there's one 0 pair, and there's another 0 pair. If you wanted to see those original dots, there they are. And so anytime I make a set of 0, I'm going to figure out what's left over. And sure enough, I have 2 left over, which is my final answer. Okay, let's take a look at a couple other ones. Let's go ahead and do -3 plus a -5. So I'm going to start off at 0, and I'm going to move to -3. 1, 2, 3. Okay, here I am, right at -3. Now, it also said -5. Actually, I'm going to erase it just real quick because I don't like that one. Let me change the font size. There you go. Okay, so I'm going to start again at 0, and I'm going to move to -3, make it a little smaller. 1, 2, 3. There we go, right at -3. If it says adding a -5, that means I'm going to go farther to the left because every time I subtract on a number line, I'm going to move to the left. So I'm going to move 5 to the left from here. 1, 2, 3, 4, 5. That means if I subtract 3 and subtract 5, that means at the very end I'd be at 1, 2, 3, 4, 5, 6, 7, 8, right at -8. If I want to use those integer chips, I'm going to use 3 integer chips that are red for -3 to represent that -3. I'm going to use 5 integer chips to represent that -5. And here, there's no 0 pairs I can make because remember, anytime I want to make a 0 pair, I have to have 1 negative and 1 positive to make what we call a 0 pair, or make 0. And I can't make any zeros here. So I'm just going to add all the negatives together and I get -8. Let's try the next one. So I have -6 plus 1. Okay, I'm going to start off at 0. I'm going to go to -6. I'm going to count back 1, 2, 3, 4, 5, 6. Okay, and then I have a +1. So anytime I add on a number line, I'm going to move to the right. So from there, I'm going to add 1. And sure enough, at the very end, I'm going to count down 1, 2, 3, 4, 5. I end up right here, and I'm at -5 for my answer. Let's go ahead and do this activity with integer chips. So I'm going to go ahead and put 6 negatives, 1, 2, 3, 4, 5, 6. I'm going to put 1 positive, which is right here. And let's see if we can make any zeros. So I see 1 negative and 1 positive. That's going to make 0. And then I want to find out what's left over. And sure enough, it's 1, 2, 3, 4, 5. That's negative. All right. So we just looked at how do we use number lines and chips to help us. Normally, if we were in our classroom, we'd be using actual chips to manipulate, but you can draw pictures. Sometimes if you don't have colors, if you wanted to, you could use a filled in for the positive, and you could use an open for the negative. That's a great way to do it so you know which one is which. All right, we just learned how to add integers using number lines and integer chips. When we come back to class next time, we're going to develop the rules for adding integers, meaning how can we add integers efficiently or when numbers are too large to use a number line or integer chips. Today, we're going to finish up our activity by a little practice. So I want to know, after watching this video, after taking a few notes, writing down those important parts, what do you remember? How do you feel like you're doing on this target? So what I'd like you to do on the top of page 6, toward the top, I want you to draw 2 vertical lines and 2 horizontal lines, leaving a little bit of space inside. I would like you to write page 47, and I want you to write numbers 2 through 16. What you're going to be doing is you're going to be building a game board that we're going to be using for our next class period. You're going to complete problems 2, 4, 6, 8, 10, 12, 14, and 16 from page 47 of your textbook. Let's say question number 2 is 8 plus -2. Let's say that's the problem. What I'd like you to do is I'd like you to put that problem anywhere you want to on the board. So I'm going to do it right here. I'm going to put the number. I'm going to put 8 plus -2, and I'm going to design this problem by either using the best method or the method that I feel is best for me. So I'm going to use integer chips. I'm going to put 8 integer chips, positive, and then I'm going to use 2 negative integer chips. When we use the integer chips, don't forget we're making 0 pairs. So here's 1 0 pair, and here's another one. So I'm going to write what's left over, and sure enough, I have 1, 2, 3, 4, 5, 6. And I'm going to put the answer 6 right here in my box, and I'm going to circle it. Now, there is only 8 problems, so whatever space you have left, you can put a little free space in, and I can't wait to see what solutions you bring back, and I'm excited to play our game to see how well you did on this target. I can add integers. All right, have fun.